Hello, welcome to the video. Today we are doing a extension 1 trigonometric functions test. So before you watch this video, you want to make sure you do the test. So it's in the link in the description. Give yourself 50 minutes, then come back and I've got the work solutions. So if you've already done that, let's get started. Okay, question 1 of our trig test review. So multiple choice, which expression is equivalent to, and we have this here. You need to recognize this from your reference sheet. So on your reference sheet it has the compound angle for form. It's tan A plus tan B over 1 minus tan A tan B. And what you really just need to see here is that's a minus, that's a plus. They're the opposite signs. So what we actually have here is tan A minus B. A is 2x and B is x. So 2x minus x is x, so the correct answer is A. Okay, question 2. The angle theta satisfies. Tan theta is 1/3. Find cosine 2 theta. So what you want to do here is just draw a right angle triangle. Okay, if that's theta there, then opposite is 1 and adjacent is 3. And I can find the hypotenuse quickly with Pythagoras. That'll be root 10, which means that sine theta is opposite, which is 1 over root 10, and cosine theta is adjacent, which is 3 over root 10. And then our cos 2 theta, so double angle formula, probably easier to just use this one, cos squared theta minus sine squared theta. So that is 9 over 10 minus 1 over 10, which is 8 over 10, or 4 over 5. Okay, question 3 here. The graph of the function y equals sine 3t plus pi over 3. What would be point P? Now, point P you could think about as the end of, I guess, our first cycle there. But the trick to this one is you want to get the correct phase shift. And to do that, you need to factorize this. This will be pi over 9. So this is actually negative pi over 9. Or in other words, what is our period? Our period is 2 pi over 3. So P, the x value of P will be 2 pi over 3 and minus that phase shift, pi over 9. So correct answer here is C. Okay, last multiple choice here is what is the value of tan alpha if we have this? Now this is the auxiliary method, so we know tan alpha is, well, it's cosine here and this is cosine, so that means coefficient of cosine will be our A, coefficient of sine will be our B. So it is C, 5 over 12. Okay, question 5a is using our T formula. And it's a show question, so we want to show that our left-hand side equals our right-hand side. So let's start with that. So left-hand side, these are all on your reference sheet, so you didn't need to have them memorized, but cosine theta is 1 minus t squared over 1 plus t squared, and sine theta is 2t over 1 plus t squared. And on our numerator, let's get a common denominator, which of course will be just this bit here, 1 plus t squared, and it's just a 1, so it will be 1 plus t squared, and then it will be minus 1, and then minus a negative t squared will make plus, all over t squared, and then it's dividing by another fraction, so of course we flip and multiply there, so 1 plus t squared over 2t. Okay, and now I can cancel those, they're both on the top. On the left fraction I'll have 1 minus 1, they cancel, and I'll have 2t squared. So I basically got 2t squared over 2t, 2's cancel, t's cancel, which is t, which is the right hand side. Okay, question 5 part B. Now this one is our auxiliary method, and for the next 3 parts, and they all relate to this one. So start by finding R. Now that's going to be the square root of A is root 3 and B is 1. That's a nice one, is root 4, which is 2. And our tan alpha is B over A. So in this case our B is 1 and our A is root 3. So alpha is inverse tan of 1 over root 3, which of course we know is pi over 6. So we should sum up here by saying root 3 sine x plus cos x equals 2 sine x plus pi on 6. Okay, question 5, part B and part 2 of this one. So from the previous question we know that that is 2 sine x plus pi on 6. So that's going to be much easier for me to solve that instead of the original. So divide by 2, sine x plus pi on 6 is a half. I know when sine is a half. My base angle there is pi on 6. So when is it positive 1/2? Let's actually put plus pi on 6 here. So when is it positive half? So it's pi on 6, first quadrant, and the second quadrant. And we'll find out later we need to add the next one, 13 pi on 6, because I will be subtracting pi on 6 from all of those, so I get 0, 4 pi on 6, which is 2 pi on 3, and 13 pi on 6 minus pi on 6 is 2 pi, which does fit in that bound there. So I have 3 solutions. Okay, last part of this auxiliary method question we want to sketch, and we are sketching from 0 to 2 pi, so we've got to be mindful of that. And of course what we're really sketching is 2 sine x plus pi on 6. So amplitude of 2, period of 2 pi, and a phase shift to the left of pi on 6. So let's start. Whenever we have a sketch we want to draw a nice big axis as our x, and then we want to draw a nice big y. Let's see, about here. Okay, and I need to go from 2 to negative 2. Alrighty, so let's just get our scale here. We want to go to, it's going to be my 2 pi. Alright, so the way I like to do it is think about that phase shift as going to start at negative pi on 6. So our period is of course 2 pi. So what I want to do is I want to add quarters to that. So 2 pi divided by 4 is pi on 2. So if I add pi on 2 to negative pi on 6, then I get pi on 3 and 5 pi on 6 and 4 pi on 3. My last one's going to be 11 pi on 6. Now that's just going to help me get one cycle down. Now also just as a reference, I'm just going to put a dotted line here at 2. So I know where I'm going up to, and I'm going to put a dotted line at negative 2. So I know I'm going down to here. It looks pretty terrible, sorry about that. It's okay. And I'm going to do my actual sketch here. I'm going to do it in blue. So it's going to start here. It's going to start at the principal axis. It's going to go up to 2, down to the principal axis. So hopefully you see my blue dots here. Down to negative 2, back to the principal axis, and it will keep following on. Now I don't want to actually include part of that graph, so I'm just going to put a dotted line so you can imagine it would be there. Up to there, down to the principal axis, down to the minimum, back to the principal axis, and it would continue. And of course dotted line would go up to there, but obviously I don't want to have that point, so it's just a solid blue line there. Okay, question 5, part C, first part of that one, show that. So show that question again. So we want to do left hand side, right hand side. A couple of ways you could do this one. You could do it T formula, but I'm going to just find a common denominator, which will be 1 minus tan squared x, because they're a difference of squares. I'll have 1 plus tan x all squared minus 1 minus tan x all squared. And I can expand 1 plus 2 tan x plus tan squared x minus 1 minus 2 tan x plus tan squared x. Well, 1 minus tan squared x. Alright, let's group all of our like terms, and when we do that we end up with 4 tan x over 1 minus tan squared x, which is 2 tan x over 1 minus tan squared x, which is on our reference sheet the double angle formula for tan. So that's 2 tan 2x, which is my right hand side. Okay, part 2 of C, question 5C. We just showed that this is in fact equal to 2 tan, and it will be 2 lots of 5 pi on 12. Okay, so that is 2 lots of tan 5 pi on 6, and 5 pi on 6, and just so you should know, you should probably put that there and then start that off. Tan 5 pi on 6, well 5 pi on 6 is in the second quadrant, tan is negative, so it's 2 lots of negative 1 on root 3, so that is negative 2 on root 3, or negative 2 root 3 on 3. Question 5, part D. 3 secant squared x minus 4 tan x equals 10, and we're in degrees for this one. But what you need to remember is, we need to remember this: sine squared x plus cos squared x equals 1. That's the trig identity that is on our reference sheet, but we can also get other ones that, that involves tan and secant, or cosecant and cotangent, and that's simply by dividing, well, if I divide everything by cos squared x, then sine squared over cos squared is tan squared, cos squared over cos squared is 1, and 1 over cos squared is secant squared x. So that's how I can easily get all of my identities, but this is the one that's going to be important because I can put this into here, and then I'll have tan squared, I'll have tan, so it becomes a quadratic that involves trig. So let's do that then. Remember that identity. You can go back if you want to. So we have 3 tan squared x plus 1 minus 4 tan x equals 10. Now this is a quadratic, so we want to expand, group all our like terms together, and we want everything all on the one side. So this is negative 7. Okay, and this one does factorize. I'll let you do that yourself, but it factorizes to tan x plus 1 and 3 tan x minus 7. Okay, so tan x could be negative 1. So that is, we know that one is 45 degrees, but it's in the second and fourth quadrant. So that'll be, the second quadrant will be 135 and 315. And the other one is, I want tan x to be 7 over 3. We don't know that one though, do we? So we just need to use our calculator for the first and third quadrant. First quadrant is 66.8 degrees, and then add 180 to that to get the third quadrant. So 4 answers. Question 6, part A. Okay, 2 cos x equals secant x. Well, I can write secant is 1 over cos. Multiply everything by cos. Cos squared x equals 1. Divide by 2. Square root. When I take a square root, I must make sure I take a plus minus, which is, of course, 1 over root 2 plus or minus 1 over root 2. Now that is one that we know, so it just means every quadrant, so it's pi on 4, 3 pi and 4 second quadrant, 5 pi and 4 for the third quadrant, and 7 pi and 4 for the fourth quadrant. Okay, question 6, part B. Solve the equation 2 sine bracket x minus pi and 3 equals cosine x. I think the easiest way to do this one would be to use our compound angle formula with sine. So this one's on your reference sheet. So it'll be sine x cos pi and 3, and this is the difference, so I need to subtract here. So it'll be cos x sine pi and 3 equals cos x. And of course we know these values, so 2 sine x times, and this is 1/2 minus cos x, and sine pi and 3 is root 3 over 2, and that's cos x. Okay, the 2 actually cancels, which makes it nice, so 2 cancels with that and that, so it is sine x minus root 3 cos x equals cos x. Alright, let's group our cosines together, so I could have sine x equals 1 plus root 3, lots of cos x, and divide by cos, because then I get tan. Right, 1 plus root 3 is not a value that we know the exact value of, so we need to use our calculator, and we get 1.22, 2 decimal places, and that would be the first quadrant where tan is positive. It's also positive in the third quadrant, so I need to add pi to this, and it's 4.36, correct to 2 decimal places. Okay, question 6, part C. So we're going to use this compound angle expansion for sine 2 theta plus theta, and we're going to find an expression of sine 3 theta in terms of sine theta. So sine 2 theta plus theta, so this is like your A and this is your B, so it is sine 2 theta, sine theta, cosine theta, and we've got the sum this time, so it's going to be plus, and it'll be cos 2 theta sine theta. Now of course we want it in terms of sine theta, so sine 2 theta is 2 sine theta cos theta, so we're going to end up with cos squared here, and cos 2 theta, now we want the one that's in terms of sine theta of course, so that'll be 1 minus 2 sine squared theta sine theta. So remember your trig identity, cos squared plus sine squared, theta, sine squared theta equals 1, so I could write cos squared theta equals 1 minus sine squared theta, which is exactly what I'm going to do there. So 2 sine theta, 1 minus sine squared theta. Let's expand here, so plus sine theta minus 2 sine cubed theta. And when I expand and group all my like terms together, so 2 theta plus theta is sine 3 theta on my left hand side. The right hand side I have 3 sine theta minus 4 sine cubed theta. Okay, question 6, part C, and this is the second part of that question. We want to find the roots of 8x to the power of 3 minus 6x minus root 3 equals 0. Now hopefully this should look familiar, because in the last part of this, or first part of this question, we found sine 3 theta is 3 sine theta minus 4 sine cubed theta. So hopefully that looks pretty familiar, but if I let x equal sine theta, then I have 8 sine cubed theta minus 6 sine theta minus root 3 equals 0. And you can see here, well, I want coefficient of 3, use a different colour, coefficient of 3, coefficient of negative 4. Well, this is an 8 and this is a negative 6, so if I take out a factor of negative 2, then I end up with exactly what I want. Like this. So I know that this part here is my sine 3 theta. So negative 2 sine 3 theta. Add root 3, so I'll get root 3. Divide by negative 2 theta is negative root 3 over 2. So as a base angle, that is pi on 3, and it's negative, so I want third and fourth quadrant, so it'll be 4 pi on 3 and 5 pi on 3, that's the fourth quadrant. And let's keep going here because I want to make sure I get unique solutions. So the next ones will be 10 pi on 3 and 11 pi on 3. Divide everything by 3, 4 pi on 9, 5 pi on 9, and 10 pi on 9, and 11 pi on 9. Okay, now 4 pi on 9 and 5 pi on 9 are actually going to give the exact same answer. They're both going to be positive, and 10 pi on 9 is going to be in the third quadrant, and 11 pi on 9 is also going to be in the third quadrant, so they're going to give unique solutions. So my final answer is I want to solve for x, I don't want to solve for theta. Now remember that, what we found before, x is sine theta. So last step here would be, well, x is sine 4 pi on 9, sine 10 pi on 9, and sine 11 pi on 9. And there are our three roots, which we would expect from a cubic, or that's as many as we could get from a cubic. Okay, question 6, part D. Cos 3x minus sine 2x equals 0 from 0 to pi. I think the easiest way to answer this one is to use our complementary angles, which means I can write sine as cosine pi on 2 minus 2x. Okay, which means I've got cos 3x equals cos pi over 2 minus 2x. And then I take my inverse cosine. Now that means I have 3x. I'm going to have, that could be the same as pi over 2 minus 2x. And then it will be 2 pi minus that. Okay, then I need to do the next cycle. So 2 pi plus, and then 4 pi minus. Okay, now that keeps going on, but basically what I'm going to have is some of these will have a negative, like that one, and some of them will end up having positive 2x. Basically all the odd terms and all the odd terms are minus and all the even terms are plus. So I need to break them down. So I'm going to have 3x equals pi on 2 minus 2x, 5 pi on 2 minus 2x, 9 pi on 2 minus 2x, and so on. And then I'm going to add 2x to everything, and then divide everything by 5. Now, so I know that I'm only going up to pi, so 5 pi, oops, sorry, that's not over 2 anymore, it's over 10. So 5 pi over 10 and 9 pi over 10. And then the next one would be 13 pi over 10, which is already too big. So that's that one. Now let's look at all the blue ones. So that's going to be 2 pi minus pi on 2. So it'll be 3 pi on 2 plus 2x. And the next one will be 7 pi on 2 plus 2x. And that goes on forever. And then subtract 2x from both sides. So on the left hand side I just have x, and on the right hand side my first one is 3 pi over 2, and 3 pi over 2 is already too big, so none of those count. So my answers are just these three, and 5 pi on 10 I should probably simplify to pi on 2, but they're my three solutions. Okay, last question, 6e. Solve the equation sine 5x minus sine x equals cosine 3x, and we're going from 0 to 2 pi. All right, now this is exactly what is on your reference sheet. Cosine A sine B equals a half sine A plus B minus sine A minus B. And I guess the trick here is you do have to recognize is that is what we have going on here. So A plus B is 5x and A minus B is x. So A is 3x and B is 2x, because when I add them together I get 5x and the difference is x. So I can write, if I times everything by 2, so my left hand side is 2 cosine 3x sine 2x equals cosine 3x. Let's take everything to one side. 2 cosine 3x sine 2x minus cosine 3x equals 0. And now I can factorize. Okay, and I get this equation. So null factor law, cosine 3x could be 0. So 3x could be, when is cosine 0? It is 0 at pi on 2, 3 pi on 2, 5 pi on 2, 7 pi on 2, and so on. Now I'm going to be dividing by 3, so these are all going to be dividing by 6. So I would want to go all the way up to 11 pi on 2. And so x is pi on 6, dividing everything by 3. Pi on 2, 5 pi on 6, 7 pi on 6, 3 pi on 2, and 11 pi on 6. Okay, so there are all the solutions just for cosine 3x. Now I've kind of run out of room, so I'm just going to make some space up the top here. Okay, so we also have the null factor law here, so 2 sine 2x minus 1 could be 0. So sine 2x equals a half. So when is sine 1/2? Well, it's pi on 6. First quadrant and positive in the second quadrant. I'm going to divide everything by 2, so it's going to be over 12. So what's my next cycle will be 13 pi on 6 and 17 pi on 6. And divide everything by 2. So pi on 12, 5 pi on 12, 13 pi on 12, and 17 pi on 12. So 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10. 10 solutions in total. Okay, and that's it for today. Hopefully you did well on the test, or more importantly, hopefully you've learned something. If it's helped you out, please subscribe and hit the like button and smash the ding for notifications, and I'll see you in the next video.